Everyone, this is ratio and proportion. So a ratio uses division to compare two quantities. You can write the ratio of two quantities A and B, where B is not equal to 0 in three ways. We can write that as A to B, A with the colon in the middle, or as a fraction A over B. And of course, we cannot have B equal to 0 because we cannot divide by 0. Okay, and each of these ratios is read the ratio of A to B. Okay, and ratios should be written in the simplest form. So let's take a look at an example here. We've got John makes $350 per week, but he only takes home $295 per week. So what is the ratio of John's gross pay to his net pay? Well, that would be his gross pay is how much the total amount he makes, and then the net pay is after Uncle Sam takes his cut. So we've got 350 over 295, and then we should reduce this. So we're going to divide by 5 on the top and the bottom, and we're going to get 70 over 59. And that is the simplest form. All right, now a proportion is an equation that states that two ratios are equal. So let's look at a really basic example of this. So we have 1/2 is equal to 4/8. Okay, right? Because 4 is half of 8, just like 1 is half of 2. So this would be a proportion. All right. And one thing we can do with proportion is look at cross products. Okay, so the cross product property basically says that when you multiply across, we're going to get equal amounts. Okay, so if we look here, if we were to cross multiply and multiply these two numbers, 4 and 6, we get 24. And then if we cross multiply here, 3 and 8, we also get 24. And so these are equal. Okay, and here is this written algebraically. So if A over B is equal to C over D, then A times B is equal to B times C. And of course, again, we cannot have B and D equal to 0 because you cannot divide by 0. All right, so let's take a look at some examples here. So if we cross multiply here, you've heard of cross multiply and divide. So what we're going to do is we're going to multiply these two terms and these two terms and set them equal to each other. So 6 times x is just 6x is equal to 22 times 5 or 15, which is 330. And now we can just solve this equation here. We just need to divide by 6 on both sides, and we're left with x is equal to 55. All right. So again, this is the cross multiply part, and then we divide. Okay, so let's do another one. Cross multiply, 2 times m. 2 times m is 2m, and 9 times 12 is 108. And divide by 2, we're left with m is equal to 54. All right, so those are pretty basic. Let's look at a little bit more complicated ones. But it's still the same thing. We're going to cross multiply. This is 13, not only times k, but also times -4. So we're going to put this in parentheses here. So 13 times k and also times 4. So we're going to put that in parentheses is equal to 5 times 39 195. All right, so now we should distribute out this 13. So 13 times k is 13k, and 13 times -4 is -52. Drop down the equal sign and the 195, and now I can just solve for k. So I'm going to need to add 52 on both sides. This side cancels out, left with just 13k on the left side is equal to 195 plus 52 is 247. And the last step, we divide each side by 13, and we're left with k is equal to 19. All right, moving on. Let's take a look at this example. This example is not as difficult. We don't have to do any distributing, so we're going to do cross multiply first. So 5 times 36, that is 180, is equal to 3r times 15, which is going to be 45r. And now we just need to divide by 45 on both sides. And we're left with 1r is equal to 4. All right. Let's look at one more example of this. I'm going to erase a little bit up here so I have a little bit more room. So again, we're going to cross multiply this part here. 7 times 8. 7 times 8 is 56, is equal to 12 times c minus 3. Sorry, 112. So we're going to put this in parentheses, c minus 3. And now I just distribute out. 112 times c is 112c. And 112 times -3 is -336. Drop down the equal sign and the 56 on the other side. Now I just want to isolate this 112c, so I'm going to get rid of this -336, and I'm going to do so by adding 336. If I do it to one side, I got to do it to the other side, so I got to add 336 over here as well. Cancels out on the right side, and on the left side we get 392 is equal to 112c. And last step, to get the coefficient equal to 1, we divide by the exact coefficient in front of the variable. You do it to one side, you got to do it to the other side. And so I'm left with 1c is equal to 3.5. All right, now we're going to be looking at some proportion word problems, and some common problems you'll see are exchange rate problems, cost word problems, and enlargement or reduction problems. All right, so let's take a look here. Number 1 says the money used in Croatia is called the kuna. The exchange rate is 5.6 kuna for every $3.70. So how many dollars would you receive if you exchanged 34.5 kuna? So what we're going to do here is we're going to set up a proportion. So if I'm going to put, let's do kuna on top, be 5.6 over dollars, which is 3.70, is equal to, now if you want to just keep this simple, we have two different rows here. We've got kuna and dollars. So we're going to set up a second fraction here. If you exchange 34.5 kuna, kuna is on the top, so we're going to put this 34.5 on the bottom. And it says how many dollars, so that's what we don't know. That's what we need to find. That's where we're going to put our variable. So that's where we'll put our x. And now, just like before, we are going to cross multiply and divide. Okay? So all we have to do is multiply these two, multiply 5.6 times x, and divide that out. So 34.5 times 3.7 divided by 5.6, and you're going to get $22.79 or $22.79. Okay? All right, moving on. So we've got a cost word problem. So number 2 says if you buy 6 honeydew melons for $23.94, how many can you buy with $11.97? So let's take a look here. Let's set this up as H over dollars. So we had 6 over 23.94 is equal to, we're looking how many we can buy with 11.97. So we're going to put that on the bottom row to keep this consistent. So 11.97, and we want to find out how many melons we can buy. So we're going to put the x on top, and now we just cross multiply and divide. So we can do 23.94 times x, which is just 23.94 x, is equal to 6 times 11.97, which is 71.82. So there's the cross multiplying part. Now we divide on both sides. We get x by itself, and we get x is equal to 3 honeydew, melons. There we go. Labeling is really important when you're doing ratio and proportion problems. All right, now we're going to look at an enlargement or reduction problem. So number 3 says a rectangle is 3 inches tall and 4 inches wide. If it is enlarged to a width of 16 inches, then how tall will it be? All right, so we're going to put this as the height, or how tall it is, over the width. And so that ratio is 3 to 4. We're going to set up the proportion equal to, let's see, it is enlarged to a width of 16. So again, we want to put this on the bottom with width. So there's 16 goes on the bottom. How tall will it be? That's what we're trying to find out. So there goes our x. Cross multiply and divide. 4 times x is equal to 16 times 3. So we're left with 48 is equal to 4x. And now we just solve this one-step equation by dividing. We just did our cross multiplying. Now we divide. And we're left with x is equal to 12. And we should be more specific here, 12 inches tall. There we go. All right, one last problem. We have a scale model here. So we've got a scale drawing of a house and a scale drawn house. So we're trying to figure out what the actual height of this house is if our scale is, for every 2 inches of the drawing is 5 feet to the actual house. So I always like to label these. So obviously the inches here, this is the model. And the 5 feet, this is translating to the actual house. So I'll just put the model over the actual. And we want to figure out the actual height of the house. So that is where our x is going to go. And now we just cross multiply and divide. So 8.5 times 5 which is 42.5, is equal to 2x, divide by 2, divide by 2, and I'm left with x is equal to 21.25 or 21.25 feet.